Good morning, everybody. Welcome to sunny but cold Monday morning at Chem 11:05 with your host, me, Dr. White. All right, we got a lot to do, so I better get to it. First thing I like to talk about let me make sure you can see this all, and you can. All right, over the weekend, Sunday to be specific, Sunday afternoon, I sent out important reminder email along with this announcement. All right, this Wednesday, test number 3 will be given this Wednesday. I'll send out an email with the password after Wednesday's lecture. And at that time, I will make today's video, Monday, unavailable until after the test deadline. I decided to do that. All right, for test number 3, just a reminder, it will be this Wednesday. You'll have until Thursday, 1 p.m. to finish test number 3 and upload your answers as a single PDF file. Remember, I will take off a lot of points or even give you a 0 if you don't upload test number 1 as a single PDF file. Should take about 40 minutes to do, but take 2 hours once you start. Test number 3 will cover Chapter 6, gases, and Chapter 5, Part 2, solutions. And there'll be 20 problems, 9 pages. There'll be 5 multiple choice, and some of the questions are multiple part, A, B, C, and D, etc. It will have under gases 48 points, solutions 57. It adds up to 105. So there's 5 bonus points. And you'll need your scientific calculator. Like I said, I reserve the right to subtract a lot of points if you don't upload it as a single PDF file. And as usual, next Sunday or earlier, I'll have the test scores in Blackboard. And by then, I will go over, I'm getting ahead of myself. I will, by Sunday, also send out individual emails with your points for each problem or each answer you put on test 3. On Monday, a week from today, I'll go over that. I'll cut it out of video, the public one, but I'll send out a email to each of you with the URL, the location of a private video that you can watch if you can't come to class. And I will do later today my world famous review for the next test, test number 3. All right, the other thing I want to talk about, I'd like to remind you, the deadline for a Chem 1105 Net 12, my class, Amnesty Lab program is by the end of the day, Thursday, this Thursday, 4/27/23. Be sure to upload any lab reports that you have not yet submitted the lab report for and selfie for in order to have that lab graded. After that date, any labs 1 through 7 that have not been submitted by the Thursday end of the day, you'll get 0 points. You don't want that. All right. Now, if you've submitted a late lab or number of late labs under the amnesty program, or check the Blackboard gradebook. If you have submitted a lab that has not been graded, send me, Dr. White, an email so I can grade it. I'll try and grade it as soon as possible. This week I'm quite busy, so I hope if you send me an email today or tomorrow, to have it done at the latest by Thursday, end of the day. Maybe Friday, but I'm shooting for latest Thursday. And a number of you have labs that have not been graded because either you didn't do them or you didn't let me know that you handed them a little late. All right. Now, I have one more thing that's not an announcement. Let's go to student view, my student view, and we'll click on assignments, and you'll see the Chem 1105 Spring Extra Credit Project. And this is an optional project. You do not have to submit it. However, it's not a group project. You should use your own answers. If you don't, that's called plagiarism, and I will follow the COD code of conduct for what to do when a student is committed plagiarism and what's also in my syllabus. Please don't. All right, let's look at this. All right, why did that do that? It shouldn't have. All right, let's make this a little larger so you can see it. All right, let's talk about the extra credit project. It's 10, yes. 10 points. Now, it's due May 8th of this year, obviously. Maybe not obviously. There'll be no late projects accepted. How do you get your 10? Yes, 10 points. Well, what do you have to do? The extra credit project is to create a list of ionic and covalent molecules found in and this is important, the ingredient list of products that can be purchased, i.e., that means that is things that you can use in your daily life. You must find five different molecules that contain ionic bonds and 5 different molecules that contain, this is important, only covalent bonds. You can use 3 molecules per product. Now, to get the points, you must hand in or upload, I should change this, a printed table with the product name, the molecule name in that product, and if it's ionic or covalent. Be sure to put your name on the table. You get 1 point for each correct entry with a total of 10 possible points. Now, if you put down 12 items and 2 are wrong, even though you have 10 right, I'm going to give you only 8. I'm not going to have to guess which are the right ones. This is not that hard of a project. Now, you'll get 1 point for each correct entry with a total of 10, yes, 10 possible points. Now, to make it interesting, you can't use gasoline, water, sodium bicarbonate, carbon dioxide, ethanol, also known as ethyl alcohol, sugar, or sodium chloride, table salt, oxygen gas, nitrogen gas, and natural gas, which is also known as methane. Now, let's take a look. The first column, and if you don't know how to do table, come to my office hour or see me after class. I'll show you how to do it. You have column 1, product, column 2, molecule, column 3, bond type. Can't use Coca-Cola, but in the example, I can, or you can't use water. You can use Coke. And water is covalent. Now, if you had Campbell's chicken noodle soup, can't use sodium chloride, but I can in my example. And sodium chloride is ionic. Now, remember the molecule has to be only ionic bonds or that. A molecule that's covalent can't have ionic bonds in it. A molecule that's covalent can't have ionic bonds to it. But if it's ionic, it can have both. All right, now this is important. Ingredients must appear on an ingredients list of the product. As far as I know, I've never seen, and I've also got oxygen gas, nitrogen gas listed as do not use, air. Or if you say this molecule's in a banana, I don't know about you, but I've never seen a banana with a list of ingredients on it. Maybe you go to a different supermarket than I do. All right, this is an optional project. You don't have to do it. If you want 10, yes, 10, big 10 extra credit points, you should do it. It's like getting 10 more points on a test. Yep. Now, this is not a group project. And I've had in the past when it was face-to-face, twice now it's happened, where I could tell they copied. A couple of people got together and they changed the order, but I could tell, and so could the dean. So please, please do not copy somebody else's work or do not work in a group. That's plagiarism. And I will do what's in my, it's a form of cheating. I will do what's in my syllabus for cheating, including getting the 2 deans involved. I've done it, unfortunately, a couple of times at COD. All right, now, how do you find these things? Well, get something and look at the ingredients list. Well, let's get something. This is a favorite product of mine, especially in the winter, to put it on your lips. You probably won't see it, but first time I got to wear my reading glasses. If you had seen me all the earlier ones, and you'll see active ingredients or any ingredients. And I'll pick one, phenol. Phenol is in here. So to get 1 point, you can use this. Carmex would be the product. Phenol would be, the molecule. And then is it ionic or covalent? Well, one way of doing it is look up in Google. And here's the structure of phenol. Now, each bend in a line, this is organic chemistry, I'll teach you this later in the semester, is a carbon atom. And here, do you see anything that has a metal in it? And it would be ionic, and the answer is no. So this is a covalent molecule. Now, the other way, by the way, if you look at a molecule, if it has a metal in it, alkali metal, alkaline earth metal, or just a metal, it's going to have an ionic bond 99% of the time. So phenol is covalent. You could use Carmex phenol covalent, 1 point. Now, if you look at the ingredients list, there's a lot more, and you could get 2 more. So you got to have 5 that are totally covalent and 5 that are ionic. For each product, you can only use 3 molecules. So that means you got to get at least 4 products. And let me help you out real quick. If you look on here, ivory soap, you'll see ingredients. You can get some from here. Another place to get things for ingredients, as long as it's not on the do not use list, is open your refrigerator. Most of you have items like ketchup, mustard, pickles, and other things too. Can't use orange juice or milk, but there's a whole lot. The other place, go up to your bathroom and open up the medicine cabinet, or look at the personal care things. Now, the easiest, and I don't know about easiest, but really quick way is go to any supermarket or big box store. One, walk down the condiment where they have the ketchup, mustard, and pickles, and other good things like barbecue sauce. And if you want, take your cell phone, take a picture so you can go home and look at the labels, or bring something and write it down. Then also go to personal care aisle where the hand lotions and things like that, skin creams. That's another one. By the way, cosmetics and personal care use some very high level organic chemistry. All right, let me remind you, there's a fixed deadline, May 8th, by the end of the day. After that, I will not accept projects. Remember, it's 10, yes, 10 big points. All right, let's move on. It's time for the review for test 3. Now, on your screen, you see the test 3 review. This is in the lecture section of Blackboard. Now, when we talk about gases, the first thing you should know is 1 millimeter of mercury, that's mmHg, equal 1 torr. Also, 760, oh, I got a mistake on here. I'll have to see if I'll have to correct it. Oops. That should be 760 torr equals 760 millimeters of mercury equal 1 atmosphere. Now, while we're doing this, let me open up another file too. Now, if you look on your screen, you'll see important information. And for test 3, you can find this file in Blackboard lecture folder near the bottom, and it will be the last 2 pages of your test number 3. And here I got it right. 760 torr equals 760 millimeters of mercury, 1 atmosphere. For test 3, don't forget to use your good buddy, your good friend, unit analysis for the various problems. It will help you. Also, go back and look at test chapter 6 practice problems. And after this, I'll do chapter 5, part 2 practice problems. All right, so 760 torr equals 760 millimeters mercury equal 1 atm, which is atmosphere. You will need probably converting centigrade Celsius to Kelvin. Kelvin equals degrees C plus 273. Next, you should know Boyle's law. P1 times V1 equals P2 times V2. P1, initial pressure. V1, initial volume, where you start. P2, final pressure. V2, final volume, where you get, when you make a change, where the pressure and volume are after that change, which is why it's called final. I showed you in this one how to isolate either P2 or V2 alone on one side. Go back and look at the videos. For Boyle's law, if you see a gas problem with only pressure and volume and temperature, and the amount don't change or nothing changes, well, I should say if the pressure or volume changes and there's only pressure and volume in that problem, then it's Boyle's law and know how to use it. Next, one of my favorite mathematical chemical expressions, the ideal gas law, PV equal nRT. P is pressure, but it has to be in atmospheres. And I showed you when we went through how to do this. By the way, could be 15 points. All right, V is volume in liters. You'll always be given a weight, and you need how to convert a weight, which you learned in test 2, to moles. How do you do that? If you look at important information, test number 3, I don't have in the review because you should know how to do that already. 1 mole of a compound equals the molecular weight of that compound, and the molecular weight of that compound is the sum of all atomic weights. So that's how you convert. We've done this numerous times, and I did it for PV equal nRT problems in the problem set, how to go from weight to moles. Didn't want to go to the right screen. All right, we're back on track. Now, PV equal nRT, again, N is the number of moles. Temperature is Kelvin. Now, I've never seen a thermometer that reads Kelvin, it's degrees C. And you'll have to use this conversion to get to Kelvin. And R is the universal gas law constant, which for this class, this is a number we will use as atmosphere liter mole K. Common mistake on this type of problem. You don't convert pressure into atmospheres. You don't convert grams into moles. You don't convert temperature from degrees C to Kelvin. Now, PV equal nRT is the ideal gas law. And let me just remind you, when the temperature goes down, PV equal nRT, V and an R in your car tires stay the same. On the left side, if the temperature goes down to the right, the pressure goes down. I told you that story about the winter. And in the summer, when the temperature goes way up like it had in 1995, when a lot of people died because of the heat, Chicagoland, a lot of tires I saw blew out on the expressway or toll road, actually. Why? Because in the summer, in your car tires, the gas, the temperature goes way up. In PV equal nRT, if you don't have a blowout, V and R stay constant. Therefore, if temperature goes up, the pressure must go up. And that's why it blew out. It's like blowing a balloon too much. Bang. All right, next I talk about, when it comes to PV equal nRT, remember, you'll have to solve for something. You know how to get a loan on one side, use the proper units. Now, Dalton's law of partial pressures. Partial pressure, which I won't ask, is the pressure of a gas in a mixture of gases if it were alone. And Dalton's law of partial pressure, the total pressure of a mixture of gases, P total, is the sum of the partial pressures of the individual gases, P1, 2, 3, N. You had 7, it would be 1, 2, 3, 4, 5, 6, and 7. If you had 2, it'd just be partial pressure 1, then the other. Now, when we talked about, I like that. When I talked about, you listen, doesn't sound nice. I like when we talked about boiling point of a liquid is when the vapor pressure equals the atmospheric pressure. The bubbles come up, it has vapor gas of the liquid you're boiling, and it collapses and gas escapes the liquid. And when that gas pressure equals atmospheric, you measure the temperature of that liquid, that's the boiling point. Now, you should know what's the boiling point of a liquid mean? And the higher the altitude on Earth, the lower the atmospheric pressure. And because of the lowest atmospheric pressure, the boiling point of the liquid is much lower because you need less heat to make the gas to a certain pressure equal atmospheric, which is now lower. So you should remember that the higher the altitude, the lower the boiling point. You go to Denver, you have to cook your rice or noodles a lot longer in boiling water because the temperature there, boiling water, let's see, I think it's about 95 degrees C. And Chicagoland at 0 degrees, at sea level, we're much lower than Denver, closer to the Earth, like at it, 0. We have boiling point 100 degrees. All right, next I talked about solutions. You should know the solvent is the component of a solution present in the greatest amount. All other components are called solutes. Now, for something that looks like a solution, but it's not, ooh, fancy flashlight time. Now, there's something we call a colloidal dispersion. Those are particles suspended in a liquid, not dissolved. And how do you know it's not a solution? It scatters light. Light, this is a very fancy, high-end, really bright, two-color, too bright. And it's also red. And if this were a liquid, it is, you can see the light coming through. If this were a colloidal dispersion, no light comes through because the particles are not really dissolved. It scatters light, just like my hand is not a colloidal dispersion, but you get the idea. By the way, this is one of my favorite flashlights. It's an octagon. Is it, or is, yep, it's an octagon K9.3 made by probably the finest flashlight maker in the world right now, Hank Wang in China. Yep, in China. And he's got a strong following. You notice I got a bunch of his and other companies too. Oh, I got to show off my Hank Wang K9.3. Yay. All right, back to the review. Now, you should know, like dissolves like. Like particles are soluble in like solvents. And what that really means is polar solutes are soluble in polar solvents, and nonpolar solutes are soluble in nonpolar solvents. Know this. So what are nonpolar and polar? Well, this is something you got to memorize. I make you memorize a little. So what's polar substances? Water is the most polar substance in our world. Salts like sodium chloride, table salt are polar, and alcohols like ethanol or isopropyl alcohol are, and also sugar is very polar. Now, what's nonpolar? Vegetable oil, also gasoline, Vaseline, baby oil, and you'll learn later on, I won't put it on the list now, dirt and grease are nonpolar too. So if you take water and vegetable oil mixed together, one's polar, one's nonpolar, guess what? It's separate. If you take water and table salt, it's soluble, like dissolves like. Now, if you take vegetable oil and Vaseline, I actually had a student do this in a lab for the class, and they're soluble. And we'll learn later on, this plays an important role in how soap works. All right, now, some definitions you should be familiar with. Solubility of a solute. That's the maximum amount of solute that will dissolve in a given amount of solvent. Now, when you're at the solubility limit, you've reached it. If you have a solution and say you're putting sugar, salt, and water, you can't put one more molecule once you're at the solubility limit. And because of that, if you put any more in, it precipitates to the bottom. Now, there are certain types of solutions you should know. Saturated solution contains the maximum amount that can be dissolved under those conditions of that solute. Dilute solution, you should know, contains a small amount of solute relative to the amount that could be dissolved. A concentrated solution contains a larger amount. I don't know if you saw it in the video relative to what be, but if you look on your screen, you'll see, I don't get any kickbacks from this company, a can of Minute Maid frozen concentrated orange juice, or it is called frozen concentrate orange fruit juice frozen concentrate. And what that means is you squeeze the orange, there's a lot of water in the juice that you squeeze. They take a lot of the water out, freeze it, it's a lot less volume, and they sell it in a can frozen. And if memory serves me right, and I haven't had this in decades, but why I remember, you take that, put it in a pitcher container, the frozen, or you let it thaw out a little, and then you put 3 more cans of water, mix it up, and you have your orange juice. Now, when I was in college, one of my fraternity brothers, his nickname was the Beast. I won't tell you how he got that, but from X-Men. But anyways, he used to love to eat it frozen. Oh, right out of the can, concentrated orange juice. Anyways, that was the Beast. That's concentrated. Means there's a lot more solute. All right, now a very important one is aqueous solution. And that's when a solution in which water is a solvent. And it's shown by bracket A, close Q, close bracket. And that means it's an aqueous solution whenever you see that. Now, concentration, how much of a solute is present in a solution. And there are three ways. The one I asked you to learn was molarity. Molarity, which is abbreviated by a capital M. You'll see why when we go through the practice problems today. After this is a solution. Molarity of a solution is a ratio giving the number of moles of solute per liter of solution. But because 1 liter equals 1,000 milliliters, molarity equals moles of solute per 1,000 milliliters. Most of the time in a lab, 1 liter isn't that useful. Now, very important, know this. Now, once again, I gave you down here, 1 mole of an element equals atomic weight of that element in grams, and the 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights. Now, remember molarity, moles of solute per 1,000 milliliters of solution. Now, how do you make a molar solution? Well, if you want to know how many grams of a compound are needed to make so many milliliters of a certain molar solution, you use the two-step process. Step 1, convert milliliters to moles. I'll show you that in a little while. Step 2, convert moles to grams. And you'll be given this if we go look at important information. Test number 2. Open up eyes. That's number 3, not 2. And you'll see here in test number 2, here is the 2 steps. And that's the review for test number 3. I almost said 2 again. Let's try it again. And that's the review for test number 3. I got it right. Yay. All right, let's take a 5-minute break, and then I'll come back and do the solutions problems. And I'll see you in 5. I'm going to get up and stretch. Let's get going. All right, just a reminder, remember this Wednesday, I'll be giving test number 3. End of Thursday is the end of the lab amnesty, labs 1 through 7. Make sure you hand them in if you haven't. All right, let's go through. Let's get to the top. That's not what I wanted. That's what I want. All right. Oh, I apologize. I didn't realize this part of it's still in cursive. All right. This is in the answers for practice problems of Blackboard, Chapter 5, Part 2. Give an example of a colloidal dispersion that you could use in your daily life. And that first one is milk, next one is latex paint, and the last one is blood. Now, give an example of a solution that you use in your daily life. Pop is a very complex solution. Remember, Dr. White is from the Chicagoland area most of my life, except the 5 years I lived in Michigan where I got my PhD, and a few months here and there when I lived in Europe for a couple of weeks at a time or worked there. But if you're from the Chicagoland area, the stuff that's in a can or bottle that's non-alcoholic carbonated, we call pop, not soda. And that's a mixture. The air you're breathing is a mixture. Gasoline is a mixture. Tea is a mixture, or a solution, I should say. These are all solutions. And there are a lot more. All right. Now, if you have a solution, 12 grams of KBr, potassium bromide, 10 grams of water, what is the solvent? What is the solute of this solution? Well, the solvent is the component of a solution present in the greatest amount. In that case, it's the KBr, because 12 is greater than 10. G is grams, weight. And therefore, that makes all other components, in this case, 1, water, the solvent. Now, if we look at number 4, if a solution has 56 grams of ethanol, 125 grams of water, what is the solvent? What is the solute? Solvent is the component present in the greatest amount, water, H2O. Ethanol is the solute, the other components. Now, what does 1.34 capital M HCl mean? Capital M, molarity. And molarity is moles of solute per 1,000 milliliters solution. Therefore, the number in front of the capital M tells you how many moles of HCl, and it's per 1,000 milliliters of solution. Now, number 7, what does 4.56 times 10 to the third capital M NaCl AQ bracket AQ close bracket mean? What's the solvent of the solution? Well, capital M, molarity, moles of solute per 1,000 milliliters solution. So that would be 4.56 times 10 to the third moles of sodium chloride per 1,000 milliliters of solution. What's the solvent? Bracket AQ close bracket means aqueous, which means the solvent is water. AQ in a bracket means solvent is water. You know something, I haven't been sharing the fun today, so I better share the fun. And the question is, what does this mean? 2.371 capital M and AOH close bracket AQ close bracket mean, and what is the solvent? Your turn. I'll give you time to think about that, and then I'll do it. Remember, you're trying to find out what does 2.371 capital M and AOH bracket AQ close bracket mean, and what is the solvent of that solution? Time's up. Capital M with numbers and a formula. What does that mean? Well, if you look at important information, test number 3, M is molarity. I didn't put capital M there. You got to learn that. Got to do a little memorization in my class. That's moles of solute per 1,000 milliliters solution. Therefore, this is molarity, number in front, 2.371, and therefore it's moles NaOH, sodium hydroxide, per 1,000 milliliters. That's what that means. What is the solvent? This tells you. Bracket AQ close bracket tells you water, otherwise known as H2O, is the solvent. And you should know that. All right, let's look at number 8. How many moles of sodium chloride are in 125 milliliters of a 3.45 capital M NaCl solution? What do? You figure out what are you being asked to find? Moles of sodium chloride. What are you given? 125 milliliters of the solution. What are you also given? 3.45 capital M NaCl. As soon as I see that, I know what does that mean, and I write it down. And here, in case you forgot, molarity, capital M, moles of solute per 1,000 milliliters solution. Therefore, it's 3.45 moles of sodium chloride, table salt, per 1,000 milliliters. Now, the only number I have is 125 milliliters. I want to get to moles of sodium chloride. So it's time to use your good buddy, your good friend, unit analysis. Whatever we're trying to get to, the units go on top of a ratio to convert milliliters to moles of sodium chloride. Whatever I'm trying to get rid of goes underneath. Where do I get these numbers? From the molarity. 3.45 moles of sodium chloride per 1,000 milliliters. I put that in there. Milliliters divided by milliliters cancel out. I'm left with moles of sodium chloride. And there's the answer. Now, I haven't mentioned this. On test 3, underneath your name, it will say, please use proper significant figures for all calculated answers. It will also say, please use 3 significant figures for all atomic weights. If you notice here, we have 125, 3 significant figures. 3.45, 3 significant figures. The 1,000 exact number does not play a role in the final number of significant figures of your answer. And for a multiplication division, you get the same number of significant figures in your answer as the number you're multiplying divided that has the lowest significant figures. 3, 3, exact number, 3, and you know how to round off. And 9 and 10 are the same. Now, let's look at number 11. How many grams sodium chloride are needed to make 345 milliliters of a 6.789 capital M NaCl solution? Whoa, what do we do? Well, you find out what are you given, or what are you trying to find first? How many grams of sodium chloride? Because you know by now, with a question mark, grams for sodium chloride. Now, before I go any further, important public service announcement from me, Dr. White. On test 3, like test 2, there are going to be some big point problems. Show your work. If you put the answer down, nothing else, and it's not the right answer, you get 0, 0, 0. See? 0 points. You don't want that if you make a math error. However, if you show your work, I can say, oh, you made a math error there. I'll take off 1 point. Oh, you did a rounding error. Or there's a couple of steps. You got this step wrong, but the other 2, I can give you partial points. And some points are better than 0. So show your work. And then a public service announcement. Now, if we look at this, what are we given? Again, the question is, how many grams of sodium chloride are needed to make 345 milliliters of 6.789 capital M NaCl solution? We're trying to find grams of sodium chloride. We're given the milliliters of solution, 345. We're given this number, 6.789 capital M NaCl. When you see capital M, what does that mean? Molarity, moles of solute per 1,000 milliliters, molarity. And that means 6.789 moles of sodium chloride per 1,000 milliliters. Now, you can't go from milliliters to grams directly. You can't. I can't, meaning you can't either. So what do? You look at molarity 2-step problem, which this is. Milliliters to moles, first step. Second step, moles to gram. Again, you'll be given this page, but you still have to know how to use it. All right, so first step, milliliters to moles. Well, we have 345 milliliters. We're trying to get moles of what? Well, eventually sodium chloride, but at this point, moles of sodium chloride. Whatever compound you're trying to get to, like this case, grams of sodium chloride, that would be moles of that compound. And now we have a ratio to convert milliliters to moles of sodium chloride. What do we put on there? Use your good friend, your good buddy, unit analysis. Moles of sodium chloride go on top, milliliters go underneath. Where do I get those numbers? From the molarity, 6.789 moles of sodium chloride per 1,000 milliliters. And I put that in here. And I'll do the calculation. Remember, 345, 3 significant figures. Ooh, 6.789. 4 significant figures. And the 1,000 is an exact number, plays no role in significant figures. And for multiplication division, you get the same number of significant figures in your final answer as the number you're multiplying dividing as the fewest significant figures. Well, this is 3. All non-zero numbers are significant. This is 4. 3 is less than 4. I like the fancy hand signals here. But anyways, so my answer should be 3 significant figures. Now, if you notice, you're doing 2 steps, calculations. For multi-step calculations, there are 2 philosophies. Not my philosophy, the one I use, I round off at each step. What is practice problem is thirsty work. And the other is round off at the end, which I don't do. However, on my test, I will calculate both ways and both will be acceptable. A lot of times the number is the same. Sometimes they're different. They're different. They'll both be correct answers. All right. Now, we've just done step 1. We found out how many moles of sodium chloride you need to make 345 milliliters solution. But are we done? No, we're trying to find grams of sodium chloride. So now we need step 2. In case you forgot, step 2, moles of a solution, moles to grams. So we have 2.34 moles of sodium chloride. We want to get to grams of sodium chloride. We had a ratio, which what will we use to convert moles of sodium chloride to grams of sodium chloride? Well, it's time to use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to goes goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. And moles divided by moles is the number 1, not 11. And so I'll have the right units. So now I can do the multiplication. Not yet. What do I fit in here? 1 mole of a compound equals how many grams of that compound? 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of that compound is the sum of all atomic weights. So what I need, 1 mole of sodium chloride, how many grams? What's the molecular weight of sodium chloride? Well, sodium, there's 1 of those and 1 chlorine. Remember, round off your atomic weights to 3 significant figures. In that case, it's 23.0 for sodium, 35.5 for chlorine. Add them up, you get 58.5. Remember, when you do addition, get the same number of significant figures to the right of the decimal as the number with the fewest. In this case, 3. Oh, I'm getting ahead of myself. 1. This 23.01 significant figure to the right of the decimal. And this is 35.5, 1 to the right of the decimal. Add it up, you get 58.5, 1 to the right of the decimal. So for every 1 mole, there's 58.5 grams of sodium chloride. Now, 1 is an exact number, 3, your answer should have the same number of significant figures as the number that you're multiplying and dividing, both are 3, and you round it off to 3 significant figures. Now, just remember, most of you have your calculator in scientific notation. And if you didn't, the answer key 137 both ways, scientific notation, that's 1.37 times 10 squared, which is the answer. Either way is correct on my test. Did I tell you I'm that close to the person grading the test? Me. Now let's look at number 12. How many grams of H2SO4, that's sulfuric acid, are needed to make 345.5 milliliters of the 6.77 times 10 to the minus 2 capital M H2SO4? You haven't done it already. I'm going to let you first of all find out what are you being asked to find. Your turn. And also, what are you given? Don't peek at the screen. Don't peek at the screen. All right. The answer is, what are you being asked to find? How many grams of H2SO4? You're given these many milliliters, 345.5 milliliters. You're given this number, 6.77 times 10 to the minus 2 capital M, H2SO4. Capital M tells you molarity. And molarity is moles of solute per 1,000 milliliters solution. So what does this mean? It means 6.77 times 10 squared moles of H2SO4, sulfuric acid, per 1,000 milliliters. And now we can say, oh, milliliters to grams, can't do that in one step, but I can do it in two steps. Now, one thing I left off on this in the previous problem, 10 points each. 10 points each. And how do we go from mils to grams of a solution problem? You look at important information, test number 3, and molarity two-step, milliliters to moles, and then moles to grams. So you go from milliliters to grams in two steps, two steps. So step 1, milliliters to moles. Here's our milliliters. We want moles. Whatever we're trying to get to goes on top of that ratio, moles of H2SO4. Whatever we're trying to get rid of goes underneath that ratio. And where do we get these numbers? From what the molarity is of the solution we're trying to make. 6.77 times 10 to the minus 2 on here. I think I made a mistake. I have minus 2 here. I have 2 here. Well, let's assume that should be 10 squared. So you can see the problem, right? Oh, don't look, mistake. But anyways, so we have, and by the way, if you did that, I'd see, oh, you wrote that wrong. I'd only take out 1 point. You didn't show your work. I'd give you 0. So at least I didn't get 0. But anyways, let's use 10 to the squared instead of minus 2. My mistake. And here's the milliliters. We're trying to get the moles. Whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. Where do we get that? From the molarity. Do the math. Get the same number of significant figures in your answer as the number you add and subtract that has the fewest significant figures. 4, 3, the 1,000 is an exact number, and that would be 3 significant figures. Now notice milliliters divided by milliliters cancel out. Anything divided by itself is number 1, gone. I like that, gone. Slow motion. Gone. All right, and now we have moles of H2SO4. Are we done? No, we're trying to get the grams of H2SO4. We need 2 steps. Second step, moles to grams. I have these many moles of H2SO4. I'm trying to get the grams of H2SO4. I'll use my good buddy, my good friend, unit analysis. Wherever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. Where do I get a relationship between moles of a compound and grams of a compound? Well, you look at a test, excuse me, 3 important information. 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights. Remember, use all atomic weights, 3 significant figures. And for H2SO4 over here, 2 hydrogen, 1 sulfur, 4 oxygen. Each hydrogen has atomic weight of 101, 1.01. Each sulfur, only 1, 32.0. Each oxygen, 16.0. Multiply each by number of atoms in that molecule, 2, 1, and 4, and you get this number. Add them up, you get the same number of significant figures to the right of the decimal as the number with the fewest significant figures to the right of the decimal. 2, 1, 1, round that off to 1 significant figure to the right, 97.0. Therefore, 1 mole equals 97.0. Moles of H2SO4 divided by moles cancel out. We're left with what we want, grams, yay. And now we do the math, 3, exact number. Round our number on the calculator to 3 significant figures. And remember, I made a mistake. That should be -2, but anyways, and that's how you do it. And that's how you do practice problems for solutions, chapter 5, part V, part 5 or part 2. And that's that. Oops, zoned out again. Sorry. I had a hard night's sleep. Oh, heck of it. All right, we're done with that. Let's go now. I've got to open it up to pH. And not pH, to acids and bases. I got ahead of myself. Let me close this window. Let me close this window. And we're talking about acids and bases. Let me remind you, Brønsted Lowry Acid, which henceforth I'll just call an acid, is a proton donor. An acid is a proton donor. And proton is H+. So Brønsted Lowry Acid, or an acid, is a proton donor. In your stomach, you have hydrochloric acid. And that's a proton donor. That's how it helps break down your food. We'll talk about that later on. Now, a Brønsted Lowry base, which henceforth I will call a base, is a proton acceptor. If I'm a base, I'm going to say, give me your protons. I'm a base. Remember, a proton is H+. Now, we're talking about conjugates when we ended up with this last week. We talk about conjugate pairs, acid-base pairs. And a proton transfer that does not happen 100% in acid-base reactions, it's an equilibrium. And you know that by this double-headed arrow. And this tells you the double-headed arrow is an acid-base equilibrium. Now, this is an acid, and its conjugate is this. How do I know it's an acid? Because when you go from HA to its conjugate, it loses a proton. This count hydrogens is easier for you. And this would be its conjugate. Now, this, when it goes from left to right, is a base. And here's its conjugate. By definition, on acid-base reactions, on the right side of a reaction equilibrium, you'll always have the conjugates. Now, what kind of conjugate you have to determine? When A minus goes back to HA, does A minus accept the proton or donate hydrogens? It accepts a proton. An proton acceptor is a base. So A is the conjugate base of this reaction. When we look at HB plus, when it goes to its conjugate B, does it gain or accept the proton or donate, give up a proton? Count hydrogens. If there's less, it's a base. And here we have HB plus, and it goes to B, it's given up, donated a proton. That makes it an acid. Now, let me remind you, there's no rule in chemistry that the acid has to be first, base second. It can be switched. There's no rule in chemistry like I have here that the conjugate base is first and the conjugate acid is second. It can be switched. You've got to figure it out just like I showed you. All right, why don't I? There. On test, I won't abbreviate, but here I will. All right, Your turn. Name the conjugate acid base, conjugate acid, conjugate base for the following. Your turn. Again, you're naming the acid base, conjugate base for that acid base reaction. This one. All right. If you need more time, hit the pause button. And when you're done, hit the play button if you're watching this video. All right, well, let's look at this. How do we determine conjugate acid, conjugate base? On the right side, these are always conjugate. So immediately I can write like this. So C and D have to be the conjugates. A and B have to be acid and base, or base and acid. So now, if I look at ammonia, that's NH3, its conjugate is D, the ammonium ion, NH4 plus. How do I know? They differ by only H plus. Count the hydrogens. Notice both have a nitrogen. C does not have a nitrogen, so that can't be the conjugate of A. Now, if I continue on, H2SO4 has a sulfur. This one, HSO3 bisulfate anion, has a sulfur, and these are conjugates. They only differ by H plus. Count the hydrogens. So, A going to D, does it donate a proton or accept a proton? Goes from 3 to 4, it's accepted and it's got a charge. So B is a base. Ammonia, that's a base. Now, let's look at B, when H2SO4. When it goes to its conjugate, C, does it donate a proton or accept a proton? And the answer is it accepts, nope, it donates a proton. Almost tricked you there, thought I may catch you. And how do you know? 2 hydrogens to 1 and a plus or minus charge, it donates a proton. What's a proton donator, or something that donates a proton? An acid. Now, let's look at C. It's a conjugate because it's on the right side, going from C to B. Does C, HSO4 minus, accept the proton or donate? Count the hydrogens. It's accepting a proton, and a proton acceptor is a base, but because it's on the right side, it's a conjugate base. And finally, we're left with D. D goes from here to its conjugate, A. Count the hydrogens. Does it donate a proton or accept? Goes from 4 to 3, it's donated a proton. What's a proton donor? An acid. But because it's on the right, it's a conjugate acid. And that's how you do it. Oh, let's do one more. Here we have C4, C2H4O2. This is the empirical formula for acetic acid. This is a side note. You take acetic acid, (4% approximately, and 96% water, mix them together, you get a solution that's homogeneous. It's a solution, and we call that solution vinegar. Vinegar is a solution of acetic acid and water. So if you take acetic acid, react with sodium hydroxide, you will get out of room. I'm going to erase this so I can have some more room. This is called sodium acetate. I like to show charges plus water. And the question is E, F, G, and H, which is the acid, which is the base, which is the conjugate acid, which is the conjugate base. Your turn. You figure it out. Give you another 25 seconds or so. All right, let's do this. First of all, let's find the conjugates. And if we look at acetic acid, E has carbons. On the right side, the only thing that has carbons is G. So these are conjugates. If we look at F, on the right side, the only thing with hydrogen and oxygen, you don't have to worry about the sodium, is water. So F and G are conjugates. Now, by definition, everything on the right side is a conjugate. So I'll do that. You can write it out or abbreviate it on test if I put this on. Anyways, let's look at E. E going from E to its conjugate G, does it gain or lose a proton? 4 hydrogens to 3. It donates, loses a proton. What's something that donates a proton? An acid. Now, I gave it away right there when I put the name, which I wouldn't do on a test, acetic acid. Now, let's look at G going to E. C2H3O2 minus Na plus. Does it gain, accept a proton, or donate? Count the hydrogens, 3 to 4. It gains or accepts a proton. What's a proton acceptor? A base. And it's a conjugate base because you're on the right side, the side of this equation, acid-base reaction. Now, let's look at F going to its conjugate, H. It has 1 hydrogen. It now has 2 and a plus charge because OH minus Na plus. And count the hydrogen. Does it gain H plus, accept it, or donate? And the answer is it donates it. Nope, it accepts it. Tried to fool you again. And it goes from 1 to 2. What's something that accepts a proton? It's a base. And if we look from H going to its conjugate F this way, does it gain H a proton or lose it? Goes from 2 to 1. Count the hydrogens. It donates a proton. What's a proton donor? An acid. And because it's on this side, it's a conjugate acid. And that's how you do it. Now, click, switches off. Turns out not all acids or bases are equal. Some are strong, some are weak. And what's a strong acid? What's a strong base? Well, click, the switch is off. But if I look at the clock, I think we're just about out of time. So let me remind you, on Wednesday, I'll be giving test number 3. It'll cover gases. It will cover solutions. Do the practice problems. On Thursday, end of the day, is the deadline for lab 1 through 7 amnesty program. If you haven't handed in the labs, uploaded them to Blackboard as a single PDF file, please do. If you do, please email me that you're doing that so I know to grade it. Also, check Blackboard, the grade center. If you've handed in a lab and it's 1 through 8 I've graded, and I haven't graded it, email me and I'll look into it. Maybe you handed it in a little bit late. I had already graded the labs for that lab. I will go back, and if it's like a day late, I won't take any points off. And don't forget, Tuesday night and Wednesday night, I will be having my office hours. If you have any questions, stop by. And don't forget, today's video, Wednesday through Thursday, the time when you're taking test 3, I will be making it unavailable. And after the test, I'll make it available again. And with that, I'm going to say goodbye. Gang gesund. Goodbye now. I stole that from Granny to Beverly Hills, but gang gesund. Goodbye.